write down the coordinates of the x-intercepts of G in terms of P. So that is 6.1. Right, so before we actually answer the questions, if you want past papers and study material, visit allpastpapers.com. Past papers and study materials at allpastpapers.com. So let's take a look at what's happening. The graphs of g of x is equals to x plus c. This would be the straight line, and f of x equals to a divided by x plus p plus q are drawn below. Graph g and the vertical asymptote of f intersect at the x-axis. So the vertical asymptote, so that's the point where they intersect. Right. And then 6.1, write down the coordinates of the x-intercept of g in terms of p. So they intersect at the vertical asymptote. But how do we find the vertical asymptote again? The vertical asymptote would be x plus p is equals to 0, x is equals to minus p. So we know that the x value where they intersect is minus p. Okay, so write down the coordinates of the x-intercept of g in terms of p. And then 6.2, graph g intersects the horizontal asymptote of graph f at x equals to 1 and the graph f at x equals to 3. Graphs of f and g also intersect on the y-axis. Determine the equation of f. Okay, so that is 6.2. So in 6.2, the beauty in mathematics is that the answer is in front of you. You know that it's there, but can you find it? Finding it is the difficult part. So in this question, what did I do? Stick to the basics. I'm not sure what I'm doing. I'm not sure where I'm going. I'm just trying to use all the information that I'm given. So let us start. First things first, let's use what we got in 6.1. We know that that coordinate where I've placed the dot there is minus p and 0, because it's the x-intercept where is equals to 0. So let's substitute it into g of x. If we do that, we get 0 is equals to minus p plus c. So clearly c is equals to p. So we've used 6.1 to deduce that c is equals to p. Okay, we've used that piece of information. So there we go. Piece of information used. Another piece of information we have is that g and the horizontal asymptote of f intersect at x is equals to 1. G and the horizontal asymptote of f intersect at x equals to 1. So let's see. G of 1 is equals to 1 plus c. That's where g and the horizontal asymptote of f intersect at x equals to 1. So what does that tell us? That tells us that q, which is the horizontal asymptote, is at y is equals to 1 plus c. 1 plus c. Right, so q is equals to 1 plus c. We've came up with that using the fact that g intersects the horizontal asymptote of graph f at x equals to 1. So we've used that piece of information. Is there something we can come up with using c is equals to p and q is equals to 1 plus c? Not quite yet. Let's proceed and use other pieces of information that we have. The graph of f, the graph of g and f also intersect at x is equals to 3. So it means that we can say we have 3 plus c, that is from g of x, right, is equals to a divided by x plus c. I want you to realize something. In place of p, I've replaced that with c because here I've said that c is equals to p. And then plus, in place of q, I'm gonna sub 1 plus c. Okay, so where are we going with this? Oh, this happens at x is equals to 3. So I don't have to write x actually. I can write 3 there because it's when x is equals to 3 where they're equal. So if we take 1 and c to the left hand side, we get 2 is equals to a divided by 3 plus c. A is equals to 6 plus 2c. This looks like an equation. Let me call it equation 1 so long. Right. So, which piece of information have I used? The fact that they're equals to each other at x is equals to 3. And then another piece of information. Graphs f and g also intersect on the y-axis. It looks like it's that point, y-axis, where they intersect, and x is equals to 0, right? So if x is equals to 0 at that point, we know that we're going to have x plus c for g of x, which will just give us c because x is 0. And then for f of x, we would have a over 0 plus p, right? But p is equals to c, so c is equals to a over c. And then plus q. We know fully well that q is 1 plus c. So you take it, look at this. If we take 1 and plus c to the left hand side, we get minus 1 is equals to a over c. So a is equals to minus c. This looks like an equation 2. So now I can say that minus c is equals to 6 plus 2c. So I'm taking what way? Minus 6 is equals to 3c. Minus 2 is equals to c. So I have c is equals to minus 2. So a will be equals to 2, therefore, because a is equals to minus c. So I have a, I have c. I know that q is equals to 1 plus c, as we can see there. Okay, so q will be equals to 1, c is minus 2. So are we saying that q is minus 1? Let's see if it makes sense. Q is equals to minus 1 makes sense. And then p is equals to, we found p to be equals to 1. Oh, p is equals to c, so we found p to be equals to minus 2, of which we're gonna have x minus 2, right? And then we get x is equals to 2, which makes sense to be there. So it seems like everything is good. G of x is equals to 2 divided by x minus 2 minus 1. Right, we're supposed to, not g of x, but f. I'm sorry for that. We're looking for f, actually. 6.3, describe the transformation that g must undergo to become an axis of symmetry of f that cuts f at 2 points. How did you answer this question? Let me know in the comment section. If you like this video, you will definitely love my course. Go ahead and click the link on my bio and you will land on this page. You will not only find the past exam questions, but introduction videos where I break down complex concepts into small pieces that are easy to digest. It is very important in grade 12 to stay ahead of your teacher, and this is what this course is for. It's very easy to navigate through the course as videos are arranged into collections. You can clearly see that we have electrostatics, work energy and power, Doppler effect, so on and so on. Do you maybe need help with study tips and creating your own timetable? We can talk about that inside the course and I can help you out. It doesn't even take a minute to join. Can't wait to hear from you.